This code helps us generate random portfolios and calculate their performance. Imagine we have different investments like stocks or bonds, and we want to see how different combinations of these investments perform. First, we import two special things called list and tuple. They help us organize and store information in a certain way. We also import a special tool called NumPy that helps us do math with numbers. Next, we have a function called random_portfolios. This function takes in some information like the number of portfolios to generate the mean returns of the investments, the covariance matrix, which tells us how the investments move together, and the risk-free rate, which is like a guaranteed return. Inside the function, we create some empty containers to store the results. We have an array called results that has 3 rows and a certain number of columns. Each column represents a different portfolio. We also have a list called weights_record that keeps track of the weights, or proportions, of each investment in each portfolio. Then, we start a loop that goes through a certain number of times. In each loop, we do some calculations for a specific portfolio. First, we generate random weights for each investment. It's like deciding how much money to put into each investment. Then, we make sure that the weights add up to 1 by dividing each weight by the sum of all the weights. We record these weights in the weights_record list so we can keep track of them. Next, we calculate the standard deviation, a measure of risk, and the returns of the portfolio using some other function called portfolio_annualized_performance. This function helps us calculate how well the portfolio is doing. Finally, we store the standard deviation, returns, and something called the Sharpe ratio in the results array. The Sharpe ratio tells us how good the portfolio is compared to a risk-free investment. After going through the loop for all the portfolios, we return the results array and the weights_record list. In summary, this code helps us generate random portfolios of investments and calculate their performance. It uses math to decide how much money to put in each investment, calculates how well the portfolios are doing, and stores the results for us to analyze later. It's like a tool that helps us explore different investment options and understand their potential risks and returns. This code helps us analyze and display information about different investment portfolios. Let's break it down step by step. First, we have a function called display_simulated_ef_with_random that takes in some information like the mean returns of the investments, the covariance matrix, which tells us how the investments move together, the number of portfolios to consider, and the risk-free rate, which is like a guaranteed return. Inside the function, we do some calculations using another function called random_portfolios. This helps us generate random portfolios and calculate their performance. The results and weights of these portfolios are stored in variables called results and weights. Next, we find the portfolio with the maximum Sharpe ratio. The Sharpe ratio tells us how good the portfolio is compared to a risk-free investment. We find the index of the portfolio with the highest Sharpe ratio and store its standard deviation, volatility, and return in variables called SDP and RP. We also create a table that shows how much money is allocated to each investment in that portfolio. Similarly, we find the portfolio with the minimum volatility, risk, and store its standard deviation and return in variables called SDP_min and RP_min. We create a table for this portfolio as well. Then, we display the information about the maximum Sharpe ratio portfolio. We print the annualized return and volatility, and we show the allocation table that tells us how much money is allocated to each investment in that portfolio. We repeat the same for the minimum volatility portfolio, displaying its return, volatility, and allocation table. After that, we create a scatter plot to visualize the portfolios. Each dot on the plot represents a portfolio, and its position shows the volatility and return of that portfolio. We use different colors and markers to highlight the maximum Sharpe ratio and minimum volatility portfolios. Finally, we give the plot a title, label the axes, and add a legend to explain the markers on the plot. In summary, this code helps us generate and analyze different investment portfolios. It calculates their performance, finds the portfolios with the maximum Sharpe ratio and minimum volatility, and displays information about these portfolios. It also creates a plot to visualize the portfolios and their characteristics. It's like a tool that helps us explore and understand the performance of different investment options.